the third part of the introductory lecture on usability and human factors. At the end of this final lecture, students should be able to demonstrate concept knowledge of principles of user-centered design, methods of cognitive research, and sources of usability evidence, describe the role of human factors and human-computer interaction concerning patient safety in the healthcare setting, demonstrate concept knowledge of principles of user-centered design and sources. In the next few slides, we will be discussing some principles of good and poor design. One example of a good design is the point-of-sale system. This system is widely used and very intuitive. What makes it intuitive and simple is the layout is effective. One can disagree with the aesthetics of the color scheme, but the contrasts are very clear. The options are clearly laid out on the display, and it allows you to monitor the calculations in real time on the very same screen. This serves to minimize memory load and reduces the likelihood of an error. This is an example of a computer provider order entry system. It is a vitally important tool used for managing patients, ordering medications, ordering laboratory tests, and so forth. This system is central to the practice of medicine. Unfortunately, they are extraordinarily complex and have a steep learning curve. In just looking at this interface, you can see that it's very dense with buttons, as a wide assortment of information, a very long pick list, and it doesn't readily support task function. That may not be immediately transparent to you, but in future classes we will analyze interfaces of such systems and render certain judgments about usability. In general, MedlinePlus is an excellent site for health consumers. This page presents content related to seniors' health. It appears to be well organized and effectively presented. Of course, this image is just a static page. You will get an opportunity to interact with it and answer some questions about its usability. Think back to the usability principles that we introduced in the first lecture, on slide 9. Does it serve to minimize memory load? Is the system status visible? In this context, system visibility could be determined by clicking on a link and asking the question of whether it is easy to find out where you are relative to this front page. If users make an error, such as clicking on the wrong link, can they easily correct their error? Not all of the principles will be applicable, but it is a good way to begin conceptualizing judgments of usability. An important point to keep in mind is the target population. This is designed for seniors, and some of the answers to the above questions may be different for this population as compared to younger adults. Many of you are familiar with this controversial and confusing Florida ballot from the 2000 election. This is an interesting example of a deeply problematic interface design that was done without attention to human factors principles, resulting in significant consequences. Even something as mundane as a poorly designed ballot can result in significant usability problems and may result in genuine consequences. In a study conducted by Lynn, Vincent, and Doyle, 2002, they investigated the use of patient-controlled analgesic devices, PCA. PCA are devices controlled by patients to administer pain medication in particular doses. For example, a cancer patient or even someone with a broken leg may be given access to the PCA device to administer pain medication on their own. Before they are given to patients, the systems are programmed by nurses or technicians so that they control the overall rate of the medication administration and maximum dose for a given period of time. Excessive dose of pain medication can have severe consequences for a patient. PCA interfaces vary in complexity, and the one shown on the left-hand side is known to be problematic. For example, the buttons support dual functions. It has a very limited and poor interface and poor feedback. In fact, this device is known to have contributed to a number of patient fatalities over the course of the years. The picture on the right represents a redesign, at least the computer simulation of a redesign of the interface. In their study, Lynn and colleagues found that the original display introduced substantial cognitive complexity into the task, and that a redesigned interface that adhered to human factors principles could lead to significantly faster, easier, and more reliable performance. Although it needs to be tested in a real-world setting, it is possible that a redesigned interface could significantly reduce errors. Increasingly, there's a wide range of glucose meters and many different kinds of products available for people with diabetes to monitor their blood glucose. This is an advanced function glucose meter, roughly the equivalent of a smartphone in design. It supports an enormous range of activities in addition to obviously basic glucose measurement. You could store all sorts of information about your food intake, exercise, doctor's visits, and more. It's potentially a very powerful tool. Unfortunately, it's exceedingly complex to use. We tested this tool amongst older adults and found that this tool is too complex for them to use productively. If one is a regular user of a smartphone or a similar device, you may be able to more effectively negotiate this system. But many patients, especially older ones, are likely to experience considerable difficulties. This is obviously not a medical technology. Rather, it's a car stereo system. It's a system that, in my opinion, emphasizes form over function. So there are numerous buttons. Though it's not visible, they have very small fonts that are barely readable. You have this fancy animation sequence, which may be cool for a short period of time, but it's not a very productive use of space. Just an aside, car stereo systems contribute to more car accidents than cell phones. So human factors can play an important role even in this particular context. Increasingly, you'll see photocopiers of immense complexity that support a very wide range of tasks, of course from basic photocopying to complex collating. The vast majority of users require only a small subset of those functions. Yet this manifest diversity of functionality resolves in layers of unnecessary complexity, as evidenced in this design. I wanted to contrast a couple of interfaces. MySpace has changed over time, yet in my judgment, and this is only my judgment, it's a rather hideous interface. Certainly this particular color scheme is particularly unappealing. MySpace's use of mixed media and mixed technology, although technologically impressive, is rather difficult to negotiate. So, for example, if you have audio and video playing at the same time, and you just can't find where to turn them off because a given page may contain many media players, and you might need to scroll way down to find the right one, I find it particularly unattractive and unusable. On the other hand, Facebook. Not to sing the praises of Facebook, but essentially it's a much cleaner, more aesthetically pleasing, better segregated system. And in my view, it's much more appealing, much easier to use, much less of an eyesore than MySpace. There are many other examples of systems that are reasonably well designed. This is a common music player. It's a slightly older version, but it has a really nice layout to it. And it's very easy to use, very intuitive to learn. But the electronic box score, for those of us who are baseball fans or football fans and follow sports online, these interfaces are very well designed, easy to use, and provides easy access to real-time information. Actually, that's a pretty rare property over the Internet and web. So this is just an illustrative look at the properties of some things that we consider good design and some things that we consider poor design. We will revisit these issues multiple times over the forthcoming weeks. The unit introduced issues concerning health information technology and how they presented opportunities to improve patient safety, but can also contribute to the compromise of patient safety. Human-computer interaction and human factors are disciplines that bring a set of methods for studying design and potentially improving patient safety. Usability is recognized as central to the design of effective, easy-to-use, and safe systems. In subsequent sections, we will revisit the concept of design and usability in a range of health technology contexts. patient safety.